Dividing polynomials using synthetic division. Do you remember when we had to divide 512 by 5? So when you first learn how to divide this, you set up 512 and then we divided it by 5, like this. And you ask, how many times does 5 go into 5? Once. And then you multiply, you subtract down to get 0, then you bring down the next one. 5 goes into 1 0 times, so then you bring down the next one. And 5 goes into 12 2 times. 2 times 5 gives you 10, and when you subtract, we get 2, and we have a remainder of 2. So your final answer is 102 with a remainder of 2. So what happens if I ask you to take a polynomial and divide it by a binomial? It's going to be a little more complicated than dividing numbers, so I'm going to teach you a method called synthetic division to divide those. So in using synthetic division to divide polynomials, our first step is to find the 0 of the divisor and place it in a box. So here's our divisor, is what we're dividing by, and then we want to take the 0. Remember, it's the opposite of this factor. So it's going to be a positive 2, and then we're going to place it inside of kind of like a half box. And then in step 2, write the coefficients of the polynomial in descending order. Substitute 0 for any missing terms. So we have x cubed, x squared, x to the first, and x to the 0. So we don't have any missing terms. So let's go ahead and write the coefficients. Positive 1, positive 2, negative 6, and negative 9. Okay, then I'm just going to make this line straight across, and we're done with step 2. For step 3, it says bring down the first coefficient. So that 1, we're just going to bring it straight down on the other side of that line. Then for step 4, it says multiply the coefficient by the divisor and add it to the next coefficient. So the idea is you're taking this 2, multiplying it by 1, and then we're going to place it over here. 2 times 1 is 2. And then add it to the next coefficient. So you're going to add these two straight down this way. So 2 plus 2 is 4. We're going to repeat step 4 until we get through the last coefficient. So take our 2, multiply it by 4, and that gives us 8. Then we want to add down. Negative 6 plus 8 is going to give us 2. And then 2 times 2 is 4. And then we want to add down. Negative 9 plus 4 is negative 5. So now we're done. And lastly, it says write your quotient using the remaining coefficients with degree that is 1 less than the initial polynomial, with any remainder written over the divisor. So this is a mouthful. So basically what's going to happen is you're going to take the degree of the original polynomial and start 1 less than that. So we're going to start off with x squared, and these are going to be our coefficients. So it's going to be 1x squared plus 4x plus 2, and then since negative 5 is our remainder, we're going to put minus 5, and you put that over the original divisor, which is x minus 2. So this is going to be our answer when you divide x cubed plus 2x squared minus 6x minus 9 by x minus 2. So let's go ahead and work out a couple more examples. So first, we want to start off with our divisor and turning the factor into a 0. So that x plus 3, the 0 is actually minus 3, and we'll put that in our little box. And then we're going to go ahead and write our terms. And this one we need to be careful. We have an x cubed, and then it goes straight to an x to the first power. We're missing that x squared term. So this is where we need to substitute a 0 for that missing term. So the coefficient of x cubed is 1. That missing term x squared, we're going to put a 0. And then for x to the first, we put negative 10. And then our constant negative 24. Then we can go ahead, draw our line, and then start our process. Bring down the very first coefficient, and then we'll start to multiply and then into this spot and then add straight down. So negative 3 times 1 is negative 3, and when you add down we get negative 3. Negative 3 times negative 3 is positive 9, and when you add down it's negative 1. Negative 3 times negative 1 is positive 3, and when you add down you get negative 21. So then we can go ahead and write our final answer. Remember, you start with the exponent that is 1 degree less than your original polynomial. So we'll have a leading coefficient of positive 1 times x squared minus 3x minus 1. And then that negative 21 is our remainder, and we put it over our divisor, x plus 3. And here's our final answer. So I want you to go ahead and pause, try the second example, and check back with me when you're finished. So I want you to make sure that you check your work with mine and the synthetic division and make sure you didn't make any mistakes. You should have finished off with a 0, which means that there is no remainder. So your final answer should be 2x squared plus x plus 3. Next, let's talk about using synthetic division to factor polynomials. So we have this polynomial, and we're given that k equals negative 4. This is one of our zeros, and we need to find the other zeros. So we're going to take the given 0 of the polynomial and place it in the box. So we're going to start off in the same method, except this time we already have the zeros, so we just take the negative 4. And that's step 1. Step 2, divide the polynomial using synthetic division. So we'll go through our steps from before. Coefficient of 1, 1, negative 10, and 8. And then we can draw our line, bring the 1 down, multiply, and then add, multiply, and add, multiply, and add. So we use synthetic division, and then we have our remaining polynomial is going to be x squared minus 3x plus 2 with no remainder. Then we want to take the quotient, which is x squared minus 3x plus 2, and factor it to find the remaining zeros of the function. So now we're going to go ahead and take this and factor it. So we have x and x. They need to add to multiply to positive 2 and add up to negative 3. So a negative 2 minus 1, these are going to be our factors. So then our zeros, our 3 zeros are going to be x equals a positive 2, a positive 1, and the one that we were given to begin with, negative 4. These are the 3 zeros of our function. So let's go ahead and work out a couple examples using synthetic division to factor the following polynomials. So here we have this one, given one of the zeros is 3. So we start off with the synthetic, putting the 0 in the box, and then we can write the coefficients. 1, 3, negative 34, and then positive 48. And we're not missing any of the terms. So we'll go ahead and get started. Bring down the 1. 3 times 1 is 3, and when you add down, that's 6. And then 3 times 6 is going to give us 18. And then when you add down, that'll give us negative 16. 3 times negative 16 is going to be negative 48. And when you add down, we have a remainder of 0. So our polynomial is going to be x squared plus 6x minus 16. And we're going to need to factor this one. So when we factor this, we get x plus 8 and then x minus 2. So then the zeros are going to be x equals negative 8, positive 2, and then the one that we were given to begin with, 3. So I want you to go ahead, try example 2, and check back with me when you're finished. So hopefully after you use synthetic division and then you factored that remaining dividend, you got that the zeros of the function were -1/2, 1, and -2. That's it for this video.